right, let's talk about both drawing and naming alkenes according to the IUPAC rules. Okay, our first problem asks us to draw 4-methyl 2-pentene. So my first thing I want to do is look at what is the longest chain, and that's pentene. And we know pent is 5, so I'm going to draw 5 carbons. And I'm going to leave room for those hydrogens, and I don't know how many hydrogens I'm going to need until I get this a little more filled out. Okay, so you have a 5-carbon chain. This 2 tells me that my double bond is on the second carbon. So I'm going to number my carbons for now, and of course I'll erase that when I'm done, just so I can kind of keep things straight. So 2-pentene means my double bond is between the second carbon and the third carbon. And then I also have a methyl group coming off of the fourth. So looking at the fourth carbon, I have a methyl group, which is 1 carbon. So now I'm going to go back and erase my carbons, numbering, and I'm going to fill in how many hydrogens I need to make each of my carbons stable. So here I have 1 bond on the first carbon, so I'm going to need 3 hydrogens. The second carbon has 3 bonds, so I only need 1 hydrogen. Same with the next. The fourth carbon has 3 bonds, so I need 1 hydrogen, and the last carbon only has 1 bond, so I'll need 3 hydrogens. All right, on paper this looks incredibly scary. There's lots of numbers, lots of dashes, but let's just take this piece by piece. We are going to draw 4-chloro, 3,3-dimethyl-1-butene. Let's look again at our prefixes. Bute tells us that we have 4 carbons, so I'm going to draw those 4 carbons. I'm going to leave lots of room for hydrogens and anything else that I may need to add. Okay, so there's my 4, my longest chain, my 4 carbons, and remember that your longest chain has to include your double bonds. So this one tells me that there is a double bond coming off of carbon 1. So I'm just going to go ahead and make that carbon 1 and number my carbons from there. So now I'm told I also have 2 methyl groups, that's the di, 2 methyl groups coming off of carbon number 3. So here's my first methyl group. I'm going to have to erase my numbering on my carbon so I can draw my second methyl group. Okay, so that portion is taken care of. And lastly, I'm told I have a chlorine atom coming off of my 4th carbon. So again, I'm going to erase that 4 and put a chlorine molecule. Now I've addressed everything that was in the name, so I can go back and put in my hydrogens for my last step. So our first carbon has 2 bonds, which means it will need 2 hydrogens. My second carbon has 3 bonds, so only 1 hydrogen is needed. My 4th carbon is happy. He has all 4 bonds satisfied, 8 valence electrons. And my final carbon will need 2 hydrogens as it only has 2 bonds. All right, so now we're going to try naming some alkenes based on the drawings. And here we have the skeletal structure. The first thing you want to do is count your longest chain with your double bond. So I have 1, 2, 3, 4, 5, and 6, which means I am dealing with the prefix hex. It has a double bond, so this is hexene. And that molecule is cyclic, so I want to put the prefix cyclo. The rule with cyclic alkenes is that you have to give your double bond the number carbons 1 and 2. So the question here becomes, which direction do we number to get to that methyl group? So I could number 1, 2, 3, 4, and give it the 5th carbon, or do I number starting here 1, 2, 3, and give it the 4th position? And the correct answer is I want to number it in such that I can get that methyl group onto the lowest number carbon possible. So I'm going to number it using the green numbering, not the purple. Okay, so that means that my carbon, or my methyl group, is now in the 4 position. So this is 4-methyl cyclohexene. I don't have to put on there where the double bond is because the rule is assumed that your double bond starts at carbons 1 and 2, so it's just 4-methyl cyclohexene. Okay, this one is kind of scary and it's kind of a beast. My first inclination is to draw my longest chain right here because it's straight across. However, if I were to make that my longest chain, I wouldn't have a double bond in it. My longest chain has to include the double bond. So I'm going to look at two different directions where I can find out what my longest chain of carbons is. So the first is to count 1, 2, 3, 4, 5, 6. That would give me a hexene molecule. The other thing I need to be careful of is I have a really long chain coming off over here. So instead of counting 6 down here, I'm going to see if my chain gets any longer. So this would be carbon 6 and carbon 7. So this is kind of a funky molecule in that my longest chain isn't necessarily straight. Okay, so I'm going to erase my carbon numbering just for now because it would now be incorrect to number that way because I need that numbering to have the double bond on the lowest carbon. So here I can count 1, 2, and my double bond is on the third. Whereas if I count from the other direction, my double bond would be on the fourth carbon. Okay, so let's go back to naming this now that we figured out what the longest chain is. That includes the double bond, and so it is 7 carbons long. So this is a hept for the prefix, and because it has a double bond, we call it a heptene. We do, because this is not circular, need to say where that double bond is. And we see that that double bond is coming off of the third carbon between the third and fourth carbon. So next we're going to look at our functional groups. So because we've identified that as the longest chain, I have a methyl group here on carbon 3, a second methyl group coming off of carbon, this would be 4, 5, 6, and I also have a 3-carbon chain or a propyl group. I'm going to write that to remind myself. That's how I want to name it. Coming off of carbon number 4. So now, because I have 2 methyl groups and 1 propyl, I'm going to have to arrange these in order alphabetically. So M comes before P alphabetically, so I'm going to name my methyl groups first. So my methyl groups are coming off of 3. Let's write this down here where we have way more room. Okay, so we said this was a heptene with the double bond at the third carbon. Okay, so we have 3,6-dimethyl, meaning we have 2 methyl groups at carbons 3 and 6. And then we're going to go ahead and name our propyl group, which is on the 4th carbon. Okay, so this is 3,6-dimethyl, 4-propyl, 3-heptene. All right, so our last problem has us dealing with the diene, which means we have 2 double bonds in our alkene. So we're going to look at the parent chain name to figure out how many carbons long it is and the position of those double bonds. So buta tells us that it is 4 carbons long, so I'm going to start out by spacing my carbons because who knows what I'm going to be adding to them. So we have 4 carbons. Di tells us we have 2 of those double bonds, and I am going to look over here to the numbers in front of the parent chain to tell us what position those double bonds are in. So this tells us that the double bond is coming off of carbon 1. So here's carbon 1, as well as carbon 3. 1, 2, 3. So we'll put our second double bond right there. So this portion is taken care of. So next we're going to add our groups, and then we'll finish off with hydrogens. I am told I have a chlorine in the second position. Well, I've already started this off as being carbon number 1. So I'm going to go ahead and count from there. 1, 2, and I'm going to put a Cl for chloro. That's taken care of. And I'm left with 3 ethyl. So continuing down the chain, 1, 2, 3, and I'm going to put that above just so that we have room for it, is an ethyl group, which is a 2-carbon group coming off. So now all we have to do, since we've taken care of all of our groups and our double bonds, is we need to go through and fill in the appropriate amount of hydrogens to complete our octet. So on carbon number 1, we already have 2 bonds, which means I will need 2 hydrogens to complete that. Carbon number 2 has a double bond, so 1, 2, a bond to chlorine and a bond to another carbon. It already has 4 bonds. It's happy. Same with carbon number 3. It can't take any more than the 4 bonds it already has, so it will not have any hydrogens. Our last carbon has 2 bonds and nothing more, so we're going to add 2 hydrogens to give it a stable octet.